All right, this is Test 7 review. This will cover sections 2.3, 2.6, and 2.8. So the first 6 questions ask, is it or isn't it a function? So the very first picture is a circle. So you do know that if you do that vertical line test, it's going to hit in 2 locations. So this is not a function. Okay, it's not a function. Number 2, you have a picture of kind of the squiggly. And again, if you do that vertical line test, no matter where you do it, it's going to hit in 1 location. So this is a function. This is a function. Number 3 is an actual picture of one of our basic functions, which would be the absolute value function. So yes, if you do the vertical line test, or just remember that it is one of our basic functions, that you would know this is a function. And then on number 4, and it's a little difficult to see, but you just have a picture, and I'm going to do it in blue, of a vertical line, okay? You have a picture of a vertical line. So obviously, if you did the vertical line test on top of a vertical line, you're going to hit every point on that line. So this is not a function, not a function. So you do have those 4 pictures. That should be very, very simple. Determine if it's a function or not a function. Then on 5 and 6, you're given a group of points, a group of relations. So on 5, you have the points -1, 2, 9, 2, 8, 2, and 16, 2. Now, when you're looking at a group of points, you want to make sure that each one of your x's are different, that it's not repeating, because only 1 x paired with 1 y. So don't focus on the y's, because the y's do repeat on this one, but that's not my issue. It's x. X cannot repeat, and so I have different x's, so that makes this a function. Okay. Number 6, you have the point 0, 2, 8, 0, 7, 0, and 0, 6. So here, when I look at my x's, I do have 0 paired with 2, and then I turn around and have 0 paired with 6. So because your x is repeating, because it's paired with 2 different y numbers, this is not a function. Not a function. Okay? So after you're dealt with, I'm giving you some pictures. I gave you 2 relations, group of relations. The next section, 7 through 11, is you being able to look at the equation and tell me if it's a function or not a function, and then also give the domain and range. So on number 7, you have the equation x equals y to the 6th power. X equals y to the 6th power. Now, we did talk about who is in control. So when I look at this problem, my control is on y. That's the exponent. Whatever I'm doing is on the side with the y. So you don't want your y in control, because if your y is in control, then you do have the possibility of your x repeating. So this would not be a function. So you would say not or not a function in that first blank. And then underneath, you have a blank for domain, and you have a blank for range. Okay? So when I look at the fact that it's not a function, my x is not in control, okay? That means my y is in control. So when you look at the words domain and range, remember, domain means x, range means y. So if y is in control, you can plug in to the y. You can plug in what you want to. There's no restriction on what you can raise to a power. So my range would be negative infinity to positive infinity. Now, what I'm going to get out of it is going to affect my x, okay? What I get out of it is going to affect x. And since 6 is an even number, that means that I'm not going to get any negatives. I'm only going to get out of it positives. So that means the domain would be bracket 0 to positive infinity. And keep in mind that that type of interval represents all positive, okay? That's what we say when we're talking about all positive numbers, 0 to positive infinity. And that would be the case because you have a 6. It's not like it's 5 or it's 3 where you can get the possibility of a negative because you plugged in a negative. Here you're going to only get out positives. And like I said, the reason is because this is to the 6th power, okay? Number 8. You have the equation y equals the square root of 2x plus 1. So in this case, we're looking at control, and I'm dealing with square roots, and it's on the side with x. So that means x is in control. So this would be a function. So you could say function, or you can tell me yes, but in the blank for function, you need to say yes, it's a function, okay? Next blanks are the domain and the range. Now, this is a square root, okay? And the main thing about square roots is you'll never be able to get out of it a negative because we're not dealing with the imaginaries. Keep in mind, this is supposed to only produce positives if it's going to be real. So our range, and your range would be this for anything that is just y equals a square root, okay? It's going to be from 0 to positive infinity, all right? That's your range for any time you have y equals just a square root because you're not going to get no negatives. Remember, this means all positive. So there's no way I can get a negative from underneath this square root because anytime you have a negative, keep in mind, if you have a negative under a square root, that gives me that I. Okay, so we're not dealing with the imaginaries. Okay, now the domain, to find out where does this thing start to go positive, I need it to only produce positives. Well, if you don't know, things start at 0. So you need to take whatever is underneath it, 2x plus 1, set it equal to 0, and solve this basic two-step equation. And we get x is negative 1/2. So that means that at negative 1/2, this whole problem zeroes out. And that's what I need because 0 is where stuff starts to go positive. So my domain is going to start at negative 1/2 and it's going to go to positive infinity. Okay, that would be the same setup if I gave you the equation y equals the square root of x plus 3. I think we did one like this in class. The number has to be the opposite that's going to give you a 0, okay? So the domain would have to start at negative 3 and go to positive infinity. That's the same thing with this one. It's just a fraction because this produces a fraction when you set it equal to 0. So that's not to throw you off, but it's the opposite. It has to start at the number that zeroes that out. And so if you don't see it, like you can kind of eyeball it on this one. You should know negative 3 will make that become a 0. You might have to go ahead and like over here set it equal to 0 like we did here to find what that number would be. And that's negative 1/2. Okay. 9. The equation is y equals x to the 11th power. So again, we're looking at who's in control, and it's x. We're dealing with an exponent, so we know this is a function. It's a function. And like I said, you can say yes or you can put the word function in the blank for function. And so now we're looking at domain and range. Domain, if x is in control, all is on x is an exponent. I'm just raising some number to the 11th power. So it's no restriction on that number. So my domain is going to go from negative infinity to positive infinity. And so my range is my outcome. When I look at the fact that it's an 11, that's an odd number. Okay? So that's what's going to affect my range. It's going to affect y. Remember, range is y. So if it's odd, that means I have the possibility of getting a positive. If I put in a positive, I'm going to get out of it a positive. I also have the possibility of getting a negative, meaning if I let my number be negative, then I'm going to get out of it a negative. So my range would also be negative infinity to positive infinity. We have y equals 2 over x plus 9. And so is it a function? Yes, it is, because everything's on the side with x. So you would say function, yes, or you could just say the word function. And then when I look at domain versus range, domain meaning x. This is the other restriction I gave you. I only gave you 2 real restrictions. I gave you a square root, and I'm giving you a fraction. So the fraction is the bottom cannot zero out. I cannot let my denominator turn to 0. That's the bottom. So the number that puts me in danger of a 0 is negative 9. Your x cannot equal negative 9. It can equal any negative number, any positive number. It just can't be negative 9. So your notation has to skip over negative 9. So this has an actual union mark. So we're going to start with any negative number all the way to negative 9. Make sure it's in parentheses. You cannot put a bracket on this number. Now on the rest of them you can. But here it has to have a parenthesis because it does not equal negative 9. It's going to skip it. Union, parentheses, negative 9 to positive infinity. So that's coming all the way up to negative 9, skipping it, and going past negative 9 to positive infinity, okay? And again, I want to reiterate, you must put this in parentheses because it's not equal to it. I can't let it equal, but it can come close to it, okay? And we talked about this in class, that our range is what I'm going to get out of this. So there's one number that our fraction is not going to reduce to, and that's 0. Because the top number is not going to change to a 0. When you reduce that top, it's going to change to 1. So we're going to say our notation is going to look just like our domain, except where I got negative 9, I'm going to put 0. So we're going to go any negative number to 0 with a parenthesis, union, parenthesis, 0 to positive infinity. And like I said, that's dealing with that top number. This 2 is not going to cancel and make a 0. Okay? So that one is a different notation because you do have the union. And honestly, this test is Monday. This is the only one that's going to have that union mark in it, okay? So kind of know that. The one with the fraction has the union mark. Also know that when you're doing this notation, because I've seen this on tests, your infinity signs got to be on the outside. They don't go in the middle now. Your infinity signs have to start and end. Start and end the notation, okay? So kind of keep that in mind. Lastly, number 11 is not an actual equation. I did give you a picture. And the only point that's really of a concern is that first one, okay? This point here is the one that's the only one that's of a concern. So, is it a function? Yes. When you do that vertical line test, it only hits one time. So, in the blank for function, you would say function, or you would tell me yes. And then the domain. Domain means okay. what x's are included. So when I look at this picture, I'm only on the right side for my x-axis, and it's going to start at 0, okay? So my domain would be 0 to positive infinity because I'm starting at 0. I do put a bracket on it because it's included. That's a closed circle. And then my range now. Your range is your y-axis. Now, according to where it's located, 1, 2, 3. This picture is starting at 3 on my Y, and it's going to continuously to go up because you got an arrowhead on it. So my range starts at 3 and goes to positive infinity, okay? It starts at 3 and goes to positive infinity because that's where it starts on the y-axis. So here we are with 7 through 11. Those were your equations and this one picture where you have to tell me, is it a function or is it not a function? And then give me the domain and range. Now the next part of your test will be matching. You have 12 through 21 on the review sheet that's already matched for you. And what I'm requiring is you to be able to know this equation goes with that picture, okay? And that's the case for the first, let's say, 7 problems. But then at 19, I do want to make sure I make this clear on 19 and 21. 19 has 2 answers. In order to get full credit, you must give me both of these answers for this question, okay? So the question says, which graphs decrease over part of the domain and increase over the rest of the domain? So the 2 graphs, because keep in mind, this will be matching. The 2 graphs that make this a true would be the absolute value and the squaring, okay? And my picture is a little off, but the absolute value and the squaring. It says which ones are going to decrease. So if you start on the left side and follow it, we're decreasing over half of the picture. And now we're about to increase on the second half. These 2 pictures do the same thing. You're decreasing on the first half, increasing on the second half. So you would need to give me both of these 2 letters for that question to get credit, okay? Number 20 asks you which one is discontinuous at many points. That's the very last graph we did, the greatest integer function. That's that picture. Now the very last one in this section, 21, it asks for which graphs have a range of negative infinity to positive infinity, meaning all numbers, okay? That's 3 answers. I need all 3 answers, all 3 letters, in order to get that one correct. So those 3 pictures, we have the cube root function, the cubing function, and you have the actual line, diagonal line, okay? All 3 of them have a range of all real numbers. And all that's saying is which ones is going to have a part of the graph on top and bottom. And that would be the case for all 3 of these, okay? So make sure that's clear. Everyone on 12 through, let's say, 18, there's 1 answer. Picture with graph, okay? But then 19 and 21, you have multiple answers you must give. 19 has 2, 21 has 3, okay? And 20 also has 1, okay? Next, number 22 is asking you to give the intervals of the domain in which you're increasing, decreasing, and constant. All right, so here's our graph, here's our picture, and we're going to follow, I'm going to kind of highlight it in the yellow. And we're going to follow it starting on the left side, and it starts here. And if you follow this picture, we are increasing, 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 increasing. And we're doing this in the name of the domain. So my focus is those X numbers. So I am increasing, and since I'm coming from the left side, and there's an arrowhead, that would be from negative infinity, stopping at -4. Okay, that's my one interval. And then at -4 to +2, we are constant. So we are constant from -4 to 2. And I have my bracket on -4. Please make sure you notice that right here at 2, it's an open circle. So we put a bracket on -4 because it's closed. But make sure you put a parenthesis on +2 because that's an open circle. Okay? That means it's not included. And then at 2, if we follow, and I kind of got off, I'm decreasing, okay? I am decreasing. So that would be decreasing from +2. And keep in mind we're doing this in terms of the x-axis. So that's on the right side. So that would be positive infinity. Make sure you have an open parenthesis on that +2. Okay? Lastly, the last 4 questions are your function, operation, composition type questions. So it says, let's let f of x equal 4x squared minus 7 and g of x equal x squared minus 5x minus 1. Find the following. So 23, you have f minus g of -3. Okay? F minus g of -3. So here we're going to, this is an operation. So we're going to go to the f function, which is 4x squared minus 7. And in the place of x, we're going to stick -3. And you can type this directly in your calculator. Just make sure you use parentheses. 4 parentheses -3. Close it. Squared minus 7 gives us 29. Then we're going to come over to the g function, which is x squared minus 5x minus 1. And in the place of x, we're going to also put -3. And make sure you put it in parentheses so you can type it in your calculator correctly. So parentheses, -3, close it, squared, minus 5, open parentheses, -3, close it, minus 1. And so that gives you 23. So now we do what the operation tells us to, which is to subtract. So you would take the f outcome, which is 29, minus 23, and that would give you your answer of 6. Okay? So I want to make sure, and I probably should have just kept that in black. We do the operation here at the end, okay? You're going to say 29 minus 23, which gives us the answer, the final answer of 6. Okay? 24, using the same 2 functions, we're doing fg of 4. So the f function is that 4x squared minus 7. So where x is, we're going to plug in 4. And we got 4 times 4 in parentheses squared minus 7 gives us 57. And then the g function is x squared minus 5x minus 1. So where x is, we're going to plug 4 in here. And we're going to type this directly in our calculator. And we get -5. And so FG represents multiplication, okay? So you're going to say 57 times -5, and that would give us a -285. And that's your answer. Okay? Now, the next two are compositions, so keep in mind you do have the possibility. We did the minus on the review sheet as far as the operation. I could just as easily do F plus G of -3. And you would do the same thing, but you would add, okay? I could also, instead of doing multiplication, I could do division, which would be F over G, and undo it at a 4. So keep in mind you only have 4 operations, so I could do any of the 4. So you got your add, subtract, multiply, or divide, okay? Those are options. And so next we have the same two functions we're keeping, but on 25 we're doing an actual composition, which is F of G of 5, okay? F of G of 5. So when we have the little circle, that means that we're going to slightly do things different from the operation. You're going to plug in only to the function closest to the number. So it's like I'm going backwards. 5 will only go into the G function. So the G function, again, is x squared minus 5x minus 1. So where x is, we're going to stick 5. So that gives parentheses 5 squared minus 5 times 5 in parentheses minus 1. And so you get a -1. And then we're going to take -1 and plug it into the F function, okay? That's the last function that's listed if I'm going backwards. So the F function is 4x squared minus 7. So where that x is, we're going to stick -1. So you have 4 parentheses -1 squared minus 7, and you get -3. So our answer is -3. Whatever we get out that very last function is our answer. And so that would be -3. 26. You have G of F of 2. And so, again, we're going to work backwards. We're going to plug 2 into the F function. And so F's function is 4x squared minus 7. Where x is, you're going to plug in that 2. So 4 times 2 in parentheses squared minus 7 gives you 9. And then we're going to take 9 and we're going to plug 9 into the G function. That's the last one listed, going kind of like going backwards. So G's function, again, is x squared minus 5x minus 1. And we're going to plug that 9 in. So that would be parentheses 9 squared minus 5 times 9 minus 1. And we get 35. And that would be our answer. Okay? So that completes the review. Honestly, this is a very, very easy test. You have just telling me if it's a function or not a function. You have domain and range. You have matching. You have intervals of increase, decrease, and constant. And then you have your operations, function operations, and compositions.